want to go at one level and or maybe two levels and actually think about like Grover's algorithm. I think I got a pretty good understanding of the algorithm from an interference perspective, and I wanted to try to approach it like from a branching perspective, because at the end of the day, the core of Grover's diffusion operator is actually like it's a multi-control Z gate, which is kind of like in the interference interpretation or the interference explanation of Grover's algorithm that you can check out in some of in my the long Grover's playlist that I have on YouTube. It's what causes the correction of the all zero state or the all zero component, which kind of that correction makes it then, with the next layer of Hadamard's, that's what causes the amplitude amplification, really. But the other day I was playing with the idea that like the oracle, which is the portion of the algorithm that actually flags the element or elements that you want to then amplify the amplitude of, it's also a combination of control Z gates, right? And even if you think about like the smallest version of Grover's algorithm, like 2 qubits, it's a kind of a control Z, and on a full superposition or an equal superposition. And really, if you think about branching, that is sort of okay. So if you have like, let's say the positive or like the all positive superposition, right? Like that's seated by like the 0 state. You apply 2 Hadamard gates, 1 to each qubit, and then you get like the 0 0 0 1 1 0 1 1 state. And now you apply, let's say, a control Z, right? So you're flagging the element 1 1. From a branching perspective, what this means is that you're gonna have now 2 branches, right? Like one where the first qubit is 0, and so one where the first qubit is 0, and the second qubit is in the plus state, and one where the first qubit is 1 and the second qubit is in the minus state, right? So this is like it's actually a maximally like it's maximum entanglement. It's Now the second branch, the one that has like 1 in the root or in the control qubit, actually contains the element that you're flagging, right? Like if you think about like if you try to visualize a tree and the root node, so you've got like you start with the root, then you have you kind of have in the first level the 0 and the 1, and in the second level for the 0 you have like the 0 and 1, and on the second level of this of the tree, the subtree with a 1 as a root, as a parent, has a 0 and a minus 1. So that path is in that branch. Okay. So what happens if you now flag another element, right? Say for example, you flag the element. At the end of the day, like the elements. So I don't know if you can think of these as separate, like, because if you think of everything as a single tree, then it doesn't seem like this is leading anywhere, to be honest. But let's imagine we're now flagging the element 0 0, right? So you're gonna have a minus there. Let's stick with one element. What happens after? So what happens after we then apply the first layer of Hadamard's? that is in the diffusion in the diffusion operator, or the actual amplitude amplification, sorry. So when you apply another layer of Hadamard's, essentially what happens to the tree, right? Or what happens to, so let's think about, like, we're thinking in branches, so we cannot think about like the system, but we have to think about the qubits separately, sort of. And so when you apply another layer of Hadamard's, then you're going to have on the branch, like, we probably should think about it like from the bottom up of the tree. So we should think about the second qubit first, and then if you apply a Hadamard, like, one branch will go back to 0, one branch will go back to 1. I like that. Okay. And then, how can you think about now the Hadamard being applied to the first qubit, right? Because to be honest, wait a second. So to be honest, you should think of applying the Hadamard to each of the roots as well, right? Like it's a 0 or 1. It's a 0, yeah. So you kind of, I mean, what happens, it's in the plus state, right? So what happens when you apply Hadamard in the plus state is you apply Hadamard to the 0 component of it and to the 1 component of it. So this means that the roots of the branches will basically now kind of unfold, right? Like, and so you will have the 0, 1 will become 0 plus 1, and the 1 will become 0 minus 1. Oh, you've literally inverted the root. Oh, you've inverted the branches. Actually, the leaves became the roots because you got a 0 and a 1. Aha. And the roots became the leaves, right? Like, but now, okay, but now there's interference there. Now you have to apply interference there, right? Because the root, like, that was one state. I don't know how to talk about it though, but like I feel like in this case you do have to apply interference, and so you get basically, or can you? You cannot. No, you cannot apply interference. You cannot. So the 0 and the 0, like, because on one side those are now leaves. You can think of them as leaves, and so it's like the Hadamard is inverting the tree upside down. The branches is turning the leaves into roots and the roots into leaves. In this particular case, and so what did I say? The roots into leaves and the leaves into roots. That's what I meant. And so another question is, does it make sense for me to apply interference at the first qubit, right? Or it's like you now have 4 branches actually. Maybe that's not that it's inverting. It's like you've actually doubled the number of branches. So you have a branch that's like the 0 0, a branch that's like 1 0, and a branch that's like, and I'm saying the qubits from the first one, like the top to the bottom one. It's probably difficult to visualize that or think about what I'm visualizing. Maybe that kind of, it's a bit, crossing the border of what can be done in a sort of an Outloud intuition type of video, because you can't see that on the screen. But I'm thinking of like an upside down tree, and then thinking of it as separate branches, and so saying like 0 0, 0 1, 0 0, sorry, 1 0, then 0 1, and minus 1 1. So now you But that doesn't make much sense either, because that's not the point of it. Because you have 4 branches, and now what do you make up with the? At some point, these branches gotta somehow break, right? Because the next set of operations is actually control. Is actually like a not like a 2 NOT gates, one on each qubit, and then a control Z gate. And so, which will basically what it means, right? Like is okay, let's back up for a second. So I said we now have, so I'm still not sure whether you should apply interference or not in this case. Because if so, it feels like I would intuitively do, okay, on the first qubit you actually end up with like with a 0 really. But that's not true either. Like you really can't do that, like, because there's entanglement. Because those things are like they branched. You can't apply interference between branches. Like that's kind of feels like a rule, right? So you kind of end up with these 3 upside down. Let's give it a try. It's 3 upside down. Okay, so I have a 3 upside down, and then the Hadamard gates. What they've done is they've expanded the nodes, they've expanded the root nodes, and they've compacted the leaves, and so now it's like an upside down tree. Doesn't matter whether we apply now like NOT gates all over the tree, you end up with the same tree, but you don't. You end up with a tree where the minus now is at the 0, 0 branch. And so what you do is then you do a control Z. So now let's think about control Zs again as branching operations. Okay, so this means that each, let's go, that would be impossible to do with 3 qubits. At least not like these, just like thinking out loud. But 2 qubits, I think it's still doable. Now I have an upside down tree that looks like, and we're starting from the first level of the tree, so it's like minus 0, and that's connected to a 0, 1, and that's connected to the 0, and then 0, and that's connected to the 1, and 1 that's connected to the 1, exactly, to 1. So we and now what we're doing is we're applying. So let's imagine, how does this work? So how would this work intuitively? Now you have an upside down tree, and then you have a control Z operation. So what I would say is that you control on 1, right? Like, but what do you make? So you control on 1, right? Not on minus 1, not on, like, just on 1. So this means that that the minus 0, 0 branch stays as that. The 0, 0 branch stays. Sorry, the 1, 0 branch, like, it really stays untouched, right? Because the Z gate doesn't do anything on a 0. So there will be the control Z gate would have an effect, but it doesn't. Then the next branch we have is the branch with the 0, 1 where nothing happens, and the last one you've got like a 1, 1, so that turns into a 1, that turns into a 1 minus 1, into like a 1 minus 1. Okay, I like that. So what I've done here, just like on my head, is I've basically applied, and that's kind of maybe an illustrative way to think about it, because it's like that shows you that the control Z can be interpreted as like changing the face of the 1 1 element in this case, right? Because you have a tree, like you have an inverted tree, and so you got to think of those things, like you got to go through each branch, and that's what the control Z is doing, is, you know, the operations that you're applying, that the circuit, they apply to all the branches. And okay, so now we have a tree that looks like minus 0 0 1 0 0 1 1 minus 1, and now we apply another layer of Hadamard's. Okay, so again, the same story. We're kind of like gonna expand and contract things, I guess. If we start like, so what do we start? Does it make a difference? Is it still recording? I think it's still recording. It just went, yeah, that's still recording. Okay, so now you have that. Let's maybe do the top qubit where the leaves are, right? Like we have a minus. Because remember, those things are connected, right? So you should do these like per leaf group, I guess, the Hadamard gate. So the first one is like minus 0 plus 1, which is the same as 0 minus 1, which is like a minus state. So that would turn into a 1. Okay. And then the I think it's working out, man. And then the other one is like a, what did I say? So that's like it turns into a 1, and then the other one is a 0 1. Is it like these? Yeah, so that turns into a 0. Okay. Maybe that doesn't work as I expected it to work then. Because that has, sorry, I forgot to apply the other layer of X gates before doing that. So let's back up just one step. So we have like the minus 0 0 plus 1 0 0 1 and 1 minus 1 as like the 4 different branches, and now we apply like NOT gates. And so we're now at the, okay, so now like at the, basically we have like a 0 minus 0, right? 0 minus 0. So minus 0 0, that would be like, but like I'm reading it from top to bottom. So 0 minus 0, 1 0, 0 1, and minus 1 1. Okay, so we have, and then now apply the Hadamard gates and the top qubit on the sort of a leaf group, and that means that we have I'm getting so easy to get lost. I think I might have to actually do this again on an actual video, like on paper, pen and paper, or on the computer, just to make sure I didn't make a mistake here. But so you would have then the first leaf group will be 0. Wait a second. 0 1, right? So that would turn into a 0, and then the second one is like a 0 minus 1, so it would turn into a 1. So you have like the plus state again, and at the bottom you have something's wrong. At the bottom you have then basically a minus state, so that with the Hadamard turns into a 1. Something's wrong because I would have expected that in the top qubit I end up with a 1 as well, and so then I have like a 1 1, just like a 1 branch left. So we kind of we've merged the branches basically. I think that's what should logically happen, to be honest, but I think I might have messed up. Let me just do a quick run again. So without a tree, we have like the 0 plus 1, so that's two root elements, and each root then has a branch where you have like a 0 plus 1 or a 0 minus 1. Then you apply the Hadamard gate, so that basically what it does is it inverts the tree, right? Because you end up like at the second qubit you have now plus state actually, so you have like your 0 plus 1 turn into 0, your 0 minus 1 turn into a 1, and then the root elements become like a 0 plus 1 and 0 minus 1. Oh. I think that's where I made a mistake. That's where I made a mistake. Okay, because that's even so. That's even before the control Z. Like, no. Sorry, that's not correct. That's true. That's true, exactly. So the minus 1 is there. It's at the top qubit. Now I have applied the control Z and I've applied the first layer of Hadamards. Right? Good. Good. Because you have like a plus state at the top, plus state at the bottom before applying the control. So yeah, that makes sense. And now the next thing I do is, like let's for the sake of simplicity, I'm gonna skip the X gates now mentally, because I think they just don't make any sense if all I do is doing a control Z, like assuming it's like a that it affects the 0 state, right? I know that I'm cheating in here, but I think it's gonna make because I shouldn't know that, like, but I think it's gonna make my thinking process easier. So then, the question is, does these actually? Yeah, okay. So I have the 0 0, and then we have like a 0 minus 0. So yeah. So that's what we have, and now we apply another layer of Hadamards, right? And so if we start like on the top, we have 0 plus 1, so that becomes a 0. That's what I don't like. That we have a 0 plus 1, and that turns into a 0. That's what I don't like, because I should get everything to ones up there. And so if all I've done is maybe it's got to do with a minus sign, like, because the minus sign is at the bottom though. If it will be at the root, then it will be solved. Because I'll have minus 0, but that's not what's happening. Like, if I think of the phase shift happening to 0, it should happen to the bottom qubit, not to the top qubit. But it shouldn't. Something's. I'm missing something. I feel I'm missing something. I think I've been talking for like 25 minutes already now, and I can't figure it out. Okay, but at least I see the Hadamard gates seem to invert the tree. Then I must be getting wrong how the control Z like operates, right? Like on a tree like these, on the branches. How does the control operate on the branches? I mean, that's a question, right? Like. Because I think so. I think that's what I'm getting wrong. So let's go back. Let's give it another try. Okay, last try. I promise I'll stop. So we have the inverted tree, right? And so we have the inverted tree, and then we have the inverted tree. Good. Then this happens, so we have a minus there. Okay, like we have a minus at, I'm sorry, I just try to go fast, and I shouldn't try to go fast because I want you to be able to follow as well. So let's start from scratch. I have a plus state after the first hardware. So, and we apply control Z, and that creates like a tree, right? That's branching. So it creates a tree, as in like you have like the root 0 that then kind of, has the 0 and the 1 as a leaf, because the control Z didn't make any effect. And then you have another tree, another branch, that is like the 1 on the top, and then the minus state, 0, minus 1 at the bottom. And I think the trick is to keep thinking about the bottom leaves as like plus and minus states, right? Like not necessarily just like, these are not like 4 branches, actually 2 branches. And I think that's a mistake I'm making. So it's 2 branches, not 4 branches. And then, wait a second. Just want to make sure that the recording doesn't stop. Yeah, and then, good. Then we have the first Hadamard layer that turns this upside down. Okay, so we now have like the branches, like at the top they've turned the roots, like the 0 into 0 plus 1, the 1 into like the 0 minus 1. So so those is like the plus and minus correspondingly, right? And then the bottom ones, like what used to be the actual leaf, turned into like a single, into a root, right? So the plus became a 0 and the minus became a 1. We should still think about these as 2 branches, not 4. Maybe that's a mistake. Now comes the X gates layer. And what does these do? So with the X gates layer now, it doesn't affect the plus and the minus state. They both stay plus and minus. Although, maybe there's some kickback hidden in here. Because if you think about the X gate, like the 0 plus 1, still stay at 0 plus 1. The 0 minus 1 become minus 0 plus 1, but you gotta correct for that. So maybe that's, yeah. So basically, if you're gonna correct for that, you have to kick the phase up or down to the root in this case, because the root is in the second qubit. I think that's it. And so basically, you stay like with 0 minus 1, but then the root is minus 1 as well. So here we have phase kickback in Grover's algorithm. I would have never said so. Oh, okay, I like it. And it's caused by a damn layer of X gates. Wow. Now the control Z. Okay, that's tricky. So let's make sure that we understand how the control Z works in here. So because there's a control Z where the control is at the top, right? And so now that's tricky because at the top we have a plus and a minus. Those are the leaves, right? And so how do we do these? Does this mean that now because both plus and minus are like, they would act the same against like a Z, like a control on the Z-axis, because they both, like, you have like 50-50 probabilities. And so is this basically separating the branches somehow? Because now what you have is that, or it should act the control, I should probably really go branch, like sub-branch by sub-branch. So say like 0, like the 0, 0, nothing happens. The 1, 0 happens, but like really nothing happens. because it's a zero state at the bottom. And then I have like the zero minus 1, nothing happens because control is 0, and the 1 minus 1, minus 1 minus 1, right? Another question is, I think the control should be activated by these, okay? So it means that it kind of flips back the phase to like positive. So we end up like, we're now like screwed again, right? But now comes again a layer of X gates, right? And oh no, wait a second. The X gates before messed it up. Wait a second. No. We have now a so sorry. I think I should really get on the laptop and do this, because I think the phase, let's go back to when the phase kickback happened, right? The phase kickback happened, but like the phase kickback happened, but like, so you end up with like a 0 minus 1 at the second qubit, but there is an X gate applied as well, right? And so it turns into a minus 0 plus 1. And right, it hurts, because now we should do the same, and in order to do that, we just, if we want to do that, we got to negate everything. So we have like a so the minus 0 branch should now and the minus 0 is the one that actually has the branch that has this minus 1, right? So but that's then impossible, because that would be like it's like a never-ending loop, right? It's like a never-ending loop, because you would do like so you have 0 plus 1, and the zero root is attached to the plus state, the 1 root is attached to the minus state. So when you apply the X gate at the let's say you apply the X gate at the bottom qubit first, and so you have the 1 root attached to the plus state and the 0 root attached to the minus state. But now you apply the second X gate to the top, the X gate to the top qubit, and then you have the phase kickback effect, right? That this phase kickback, what basically does is, so you'll get like, so the 1 is attached to 0, so the 1 will now be attached to like to a plus state as well, and the 0 will be attached to like a minus 0 plus 1. And so we're going to correct for these. We're going to add like a minus there, and then that minus pops up as one of the root, which is 0. And that's kind of the question here, is like, is that legal? Is that legal? Is that really legal? Because now you can't just, maybe that's legal because entanglement is maybe one way, right? And so now I would just apply correction there and say, well, like that's the same like minus 0, 0 minus 1. So I just change the minuses into branches. Oh, yeah, of course. And that minus 1 kicks into the first and the top qubit, turning into a minus. and the minus that you've applied to the zero root kicks up into the first qubit, turning the minus into a plus. So you have again the 0 is connected to a plus state, and a minus 1 is connected to a minus state. Okay, and now you apply a control Z, and so the 0 branch, nothing's going to happen there. The minus 1 branch, well, you're going to turn the minus to a plus. That I don't like either. And then the hard layer will turn the root into a 1, and that into a 0. No, I don't like. But I think it's gotta have to do with these, right? So I'm gonna stop here. I gotta get pen and paper and just like do this. There's too much to do it like just out loud. Sorry for that. But there's gotta be, okay, so I've discovered that there might be phase keyback definitely here involved in Grover's algorithm, and that might be the responsible for and that really the interference when you think about branching is really the branch folding, right? Like the tree folding back into that's the interference, and it's just I think a neat way, but it seems a bit less intuitive. I liked sort of the interference way of thinking about it, although that is interference as well, right? It just feels a bit less intuitive because you have to have the tree in mind all the time. You have to have the tree in mind all the time, and so it feels a bit more disconnected, because then you need to think about like okay, so how do I manipulate a tree? Like then it sort of means like maybe there's just a tree manipulation type of algebra that like could also be a model for quantum computing. And so the Harmards, for example, right, like have that contraction and expansion effect on the leaves and the roots, and I don't know. Thanks for listening in the whole half an hour, almost 40 minutes. Stay tuned for more. Bye bye.